Thank you, Anam. Jury members, if you could please have the Bible.
Okay. So can I ask Shivram?
Yeah, please go ahead, Paritosh.
Yeah. Uh, okay, nice demo. Good to see. There are, you said that you base some of your decisions on detecting features in region of interest, ROI, right?
Yes.
So how do you decide what is the ROI and how do you engineer that?
For the wall follower ROI, it depends on the height of the wall. So if the height of the wall it is higher, that means our ROI needs to be mostly on the center,
Mhm.
right? Because the box is on the center. But in this arena, the wall height was way lower. And so even if it was on the sensor, it was detecting the background things. For example, the yellow grass and the red house over there. So because of that, I have kept my ROI in a very lower region. It will still detect the box because the box, it would take most of the part of the screen. But it will also ignore the background colors.
I see. And that worked well.
Yes, that worked very
So,
well.
see, as you approach the box, the area that the box covers in the camera changes, right?
Yes.
So, at which point do you start detecting?
This mask, it is always on. So whenever it detects, then it will know that that color is there and it will add it to our list.
Mhm. Okay. And you never had any confusion with the background.
Uh, After changing the ROIs a bit, we haven't had, I haven't had any
You
trouble.
haven't had any problem there. Okay, good. Uh, which was the most challenging part of this project for you?
The challenging part would be how to exit the junction. Entry of the junction would be easy, but how to exit the junction, that would be difficult because sometimes a robot completely, ignores that junction and continues following the circle. Sometimes it turned the wrong direction.
I see.
So yeah, so
So
I
how
fixed it.
so
I
how do you
fixed
detect the junction? Either it should be same at entry as well as exit, right?
The junction is same, but what I've done is that if all three GS sensors, if they sense black and the camera senses a color either left or right, that means it is on the entry junction. Now
I
when it
see.
is on the entry junction, if it turns left, that means the exit junction, it should also turn left. If it
Yeah,
is right, then the exit junction should also turn right.
right. Now, why should all the ground sensors be black when you are at the junction? Because the robot can be at an angle, right?
uh, because you can see on the junction there's one big black dot over there. So
Yes, but
yeah,
that black dot is not so big that it covers all the three these sensors, does it?
it may not, but it isn't entering at an angle. As you can see, it is the line. It is always at perpendicular to this black dot.
Yeah, but approximately you may be off, and you may not also be exactly on in the middle of the line. So, can it ever happen that when you are at the junction, only two of the ground sensors turn black?
That may happen, but it could happen for only one or two time steps. Third time step, most probably all three would be black.
Okay. Could you make use of this logic somehow to more robustly detect the junction and hence take a turn instead of going around the circle at exit?
We can then make it that if the middle and left or middle and right or all three are sensing black, then it should start its correct direction.
Okay. Okay. You could try something like this. Okay. How often do you process the camera image on
uh,
every cycle?
yes, on every cycle.
Is that expensive computationally? And is
uh,
it required?
It is required because for an arena like this, we don't know when the box will appear.
Yeah, but the image remains there for some amount of time. Your robot is not moving that fast that you will miss the box or crash into it or something like that. So, do you think you could do some optimization there?
Yeah, we could make it like that so that if it detects a box, then we can stop the camera detection for a while, and then after that we can continue.
Okay.
Yeah.
So, what changes would be needed in your code?
The first change first change would be my junction part, if either middle or left or middle or right or all three. And second one would be about my camera processing in the for the blocks.
Yeah, but how would you change the camera processing?
I will make it so that if it detects a box, then we stop the masks for maybe like 5 to 10 seconds, and then once the box is out of the screen, then it should start the masks again.
Okay, fine, fine. Okay, I think I am done. Shivram, over to you.
Thanks, Paritosh. So, Anam, which class are you and where are you?
Sir, I've just started my class 8 and I am in Goa, Udar International School.
All right. Okay. So, I'm seeing this line, the last line that is displaying in your code. W1 is max of min of W1 max speed minus max speed. What's going
Yeah.
on there? What is that line doing?
That is a clamp, sir. So the same thing is for WR, which is below this. This is a clamp. It is used to make sure that it does not exceed max speed. The value which we get from a proportional controller, it is used so that it won't exceed max speed and it won't exceed minus max speed.
Okay, good. So, did you, I don't know, write that line yourself, or you got, I don't know, some help from some site you saw, you used LLM help? How did you go about task of coding?
I have used some help of AI. I've used help from Claude and ChatGPT, but I have used them only for learning, maybe learning the syntax of Python, OpenCV. But the logic is purely done by me.
Okay, all right. So, it's been multiple stages, right? Like you've been working on this for several months. So, I mean, did the progression help you learn? I mean, looking back right now, can you say that some of the things you're doing right now you did not know 7 months back, and that learning happened along the way?
I have, throughout this journey of EYantra, I have learned how to use a P controller. And I have also learned how to use image processing. So there are many things that I've learned throughout this journey of 7 months. And I think the most fascinating thing would be the image processing, like how to use color detection using a camera in our ePUC.
Yeah, okay. So, of course, you've done this in simulation and so on. So, imagine that you actually deploy this on a small wheeled robot in the real world. So, the engineering students who come to Yantra competitions do it, right? Can you think of possible challenges in reality in hardware which you don't encounter in simulation to do with, let's say, image processing?
For a line follower, based on the lighting conditions, the colors may change. The
And
colors
that doesn't happen in simulation.
Yeah, that does not happen in simulation because lighting is same in the simulation, but in the real world, based on the time of this running, the colors it may change, and based on that, sometimes image processing can't recognize those colors.
That's very true. And in fact, that is something that our students who come to the finals, they realize the hard way. They've tuned it in their own labs with some lighting condition, and then they come here and it's different. They have to recalibrate. So well said. I think that's good. Do you know any programming languages other than Python?
Since fourth standard, I've been learning Scratch. I've been learning Scratch. I have learned HTML, CSS, and C++. But these are all the basics. I've learned only the basics. The Scratch and Python are my main programming languages.
Okay, so again, I asked your predecessors the same question. If you compare C++ and Python, what do you think are the main differences?
Main differences is that Python would be much easier because it uses English-like language. So these words over here, we some of these we use normally in English day-to-day life also. So learning this becomes very easy. And secondly, C++ it uses a compiler, while Python it uses interpreter. And based on that, if we have an error, it will tell us exactly at what line the error happens in Python. And based on that, it will become easy to debug also.
Good. And what is the other benefit of compiled code? If you're doing this, let's say on hardware, would you rather write C++ code and compile it, or would you be doing Python interpretation?
For me, sir, I would be using Python mostly because of
No,
it.
not you, but in practice, like industrial robots, right? Do you
Yeah,
think they're running compiled code or they're running interpreted code while they're operating the low-level control?
they would be using compiled code.
Why?
Uh,
It's faster. It's usually much faster.
okay, yes, sir.
Okay. Anyway, I think that's sort of beyond what you should be knowing in class 8, but thanks. Good demonstration.
Yeah, thank you, sir.
That was a good interaction. So thank you, Anam, for the presentation. Thank you, jury members. We'll move on to the final team for this session. Team ID 597, Advait.
Yes, ma'am.
Yeah. Second place, we have Anam Raza with her communication skill and coding skill. She just grabbed the jury members' full attention in the morning session. So kudos to Anam and her parents for consistently being
you.
there. Anam, you are there?
Yes,
Happy.
thank you, ma'am. Yes.
So,
More than happy, ma'am.
okay, nice. That was your full work that you have done, and we are very happy to see that kind of communication and sharing, all that you have learned in just a short span. So, congratulations.